Hello and welcome to a video tutorial about FreeCAD. FreeCAD is an open source 3D parametric CAD system. The homepage is located at www.freecadweb.org, and there you have access to the documentation in the wiki, you have access to written tutorials, the forum, and a lot more things. Since FreeCAD is mostly programmed in Python, that's a programming language, it is cross-platform. It is available for Windows, for Ubuntu, and for Mac OS X and Fedora. And I've also read articles in the forum, but it also runs on Arch Linux, Gentoo Linux, and other Linux systems. On Ubuntu, you have the possibility to choose between installation of a stable version from the repositories, or you can choose to install the daily PPA version via the Launchpad system. With this possibility, you are able to get the latest version, and you are able to get all bug fixes and enhancements as soon as they enter the master code. On Windows systems, you can choose between installing the stable version or a development snapshot. Of course, the development snapshot is newer than the stable version, and it does not come with an installer and with help files. That's the main difference. If you want to learn more about these possibilities, please visit the homepage of FreeCAD. I suppose that you are familiar with downloading programs from the internet and or installing them on your operational system. This is how FreeCAD will look like, or nearly look like, if you first start the program after installation. This version here is the version 0.14.3700 on a Windows 7 64-bit system. Working in FreeCAD will require you to use different workbenches. To switch from one workbench to another workbench, use the pull-down menu located here. Some of the workbenches have obvious names, and some workbenches have names which will tell you at first glance not really something new, but as you will advance in the lessons, you will learn what these workbenches are used for. The views you can see here are also adjustable. If you click on Views, you can see what viewports can be switched on and off. As you can see, I only have activated the combo view on the left side here. This is the combo view. As you can see here from the name, it is divided in the tree view and in the property view. You have also the possibility, like in other programs, to choose your preferences. For instance, you can choose your language in which FreeCAD should run, and please note that some of the settings are only available if you start the appropriate workbench for the first time per session. And as you can also see, you have, for instance, the possibility to choose which workbench should be presented at startup, and if you want to view the splash screen during startup. And what is also of importance at the beginning is the navigation style. You can choose here which navigation style FreeCAD should use, but if you don't like your choice here, you have a possibility to change the navigation style at every time to your liking. We will later on have a closer look at what navigating in 3D space will mean. So let's have a closer view about how to navigate in 3D space. For this purpose, I'm closing the start page here. I will create a new document. I will change workbench to part workbench, and I will insert a cube solid and a cylinder, just that we have two objects on the screen and that we have something to look at. As you can see here in the 3D view, we have the cylinder and the cube I just inserted, and they are also here presented in the tree view. As you can see with these icons here, you can change the way the objects look and the perspective of the view. For instance, if you set to axometric view, you will get a view like this, a 3D look, and then you can switch to the different views. You can set to front view, top view, and so on. You can also do a right click in the 3D view and see that you can set the zooming to fit all or only fit a special selection. You can change drawing styles, standard views, you can measure things, and you have also the possibility to change the navigation style. By using this button here, you can change the drawing style of the objects. You click on the black arrow down symbol here, and you can change, for instance, to a shaded view. As you can see, the edges just have disappeared. And you can also change to a wireframe mode. And this is how a wireframe mode looks like. We can change back to as is mode, and that's how the part normally would look like. As you can also see in the lower right corner, we have here representation of the coordinate system of the 3D view. How the axes are oriented in positive direction. Let's change to wireframe mode, and let's click on view and say toggle axis cross. Now this cross here has just appeared, telling us where the origin of these objects is and in which direction the positive axis will point. The red axis is the X axis, the green one is the Y axis, and the blue one is the Z axis, pointing upwards, as you can see. We will toggle the axis cross now off and switch back to as is mode. Now as for the navigation style in 3D space, I am using here on my Windows system a normal Logitech mouse. It has two buttons and a scroll wheel in the middle. So if I point with the cursor somewhere in 3D space, And if I now use the scroll wheel and turn the scroll wheel towards the screen, I will zoom in. And if I use the scroll wheel and scroll backwards towards myself, I will zoom out. If I press the scroll wheel and keep it pressed and move the mouse around, I will tilt the objects presented on the screen. As you can see, the cursor just switched to two tilting arrows. Now I let go of the scroll wheel and show you another operation possible in 3D space. I will, since I am in Blender mode, I will press down the Shift key and keep it pressed, and I will press the scroll wheel and keep it pressed, and you see that the cursor just switched to a special cross. If I still keep pressed the Shift key and the scroll wheel and move the object, I will pan the object around. If we are not familiar with moving in 3D space, I suggest that you do as I just showed you, insert one or two objects and practice a little bit moving around in 3D space before you start with the first lesson. All navigation modes, except the Inventor navigation mode, do also have an automatic recognition of faces and edges and so on. This means that if I move the cursor over a face, it gets highlighted in the 3D view. I can do the same with an edge, as you can see here, or point, as you can see here. With the Inventor navigation mode, you have to press Control and then click on the element you want to select. Please note that the 3D navigation styles are hard-coded, which means you cannot customize them. You just can choose between the three styles and you stay with one style until you want to change to another style. When talking about 3D objects, we have to distinguish between mesh objects and solids. Mesh objects consist only of faces, while solids have an inner volume. Typical file formats for mesh objects are OBJ and STL. A very well-known file format for solids is the step format. As you can see in FreeCAD, we have a mesh workbench for dealing with meshes, and when you are working with solids, you will use for most times the part workbench, which is also called part module workbench, and the part design workbench. In some cases, you will also need the draft workbench for special operations. Now if we say here Edit Preferences and look in the General section at Units, you will notice that you have a chance to change from a standard metric system to imperial units. But I have to say that the 0.14 version has very little support for imperial units. The soon-to-be released 0.15 version has more support for imperial units, but not full support. For all my lessons, I will leave the unit system to metric. So let's begin with our first lesson. I will close this document here. And for our first lesson, we are going to model this object in FreeCAD. This object is called a Turner's cube. It is a very basic lesson for programming CNC machines because in real life you would, after do all programming work on the CNC machine, you would get an aluminium cube. You would machine it to have the appropriate outer dimensions, and then you would machine on every side of the cube these 3 circular pockets. And this is how we will do it in FreeCAD as well. We will use the part design workbench to model this Turner's cube. So to begin the lesson, I will close this document here and create a new one. And then I will switch here to the part design workbench. I will switch here to the model tab. And now the basic idea of modeling in the part design workbench is to draw sketches on the main planes and then extrude them or revolve them in 3D objects. Don't worry, it sounds more complicated than it really is. So to draw a sketch, we need the sketcher. The sketcher is available as a separate workbench, or you can access it via the part design workbench, since it is needed as a basis for doing work in the part design workbench. The sketcher is represented by these icons here, and if we have an active sketch, we have also access to these icons here. A sketch can either be mapped to one of the 3 main planes or to a face of an existing object. So I will click on this icon here to start a new sketch, and then I will be asked about the sketch orientation. I will leave it to the XY plane. I don't want to have a reverse direction or an offset value, so I just press OK. And so I will enter the sketcher. I could also use now a grid in the sketcher. I myself prefer not to use a grid, but it is of course up to you to use a grid or not. So the first thing we will do is to draw a rectangle, because we will need in the first step a cube in 3D. So I click here on the rectangle icon, and then I click the first point of the rectangle, and then I click here a second time. Now all the sketches now need constraining. You can constrain either with geometric relationships or with dimensional relationships. Drawing with the sketcher needs these icons. Constraining is these icons. As you can see here, as per default, it is set up in the preferences that the sketcher should set up automatically constraints which he does recognize. So the sketcher did recognize that this line here is horizontal and this line as well. And these 2 lines are vertical. So these constraints are also applied. If I select the filter to show all constraints, I will also have the constraints that the endpoint of this line is the same as the endpoint of this vertical line. And the same applies to these here. So this shape is closed. As I click on a line, keep the button pressed and move it around, you can see the shape is closed and will move around as a closed shape. So as you can see here, the solver who tries to solve the sketch reports back that it is an under constraint sketch. FreeCAD will allow you to have an under constraint sketch or a fully constrained sketch. FreeCAD will throw error messages if the sketch has too many constraints and is over constrained. And we have 4 degrees of freedom left. Since we want the origin to be in the center of the rectangle and therefore in the center of the cube which is to be constructed, we will now use geometrical constraining. For this purpose, I click on this point. As you can see, it turns green, so it is selected. I will press Ctrl and I will keep Ctrl pressed, and then I will click on this point here and I still have Ctrl pressed, and then I will click on this X here. So I have now selected these 3 elements. And now I will use the symmetry constraint to constrain these 2 points symmetrical to this X, to this axis. Okay, we click on here, and as you can see, the shape changed a little bit. If I click now here and move the shape, you see the symmetry will be kept, and we have 3 degrees of freedom left. Okay, so now I will select this point. I will press Ctrl and keep Ctrl pressed. I will select this point and this vertical axis, and then I will also constrain symmetry. Now we have 2 degrees of freedom left. These are 2 obvious degrees of freedom: the length of the lines. Since this is a horizontal line, it is obvious that, because this line is also horizontal, that the length of this line and the length of this line are the same. If I would select these 2 lines and apply an equality constraint, this would over-constrain the sketch. So I have to undo this operation, and I now can select this line and apply a horizontal distance. I will click on here, and since I have set in the preferences a metric system, the system will ask me what horizontal distance I will set. I will set the distance to be 200 millimeters. I press OK, and the distance here is adjusted. If you made an error, or if you just want to change the distance of a constraint or whatsoever, you just double click on the 200 millimeters and then you are able to edit the distance. Now I have an obvious choice. I have 1 degree of freedom left for the sketch. I either can say I want to highlight this line or this line. That's the same, and I can apply a vertical constraint, or I can select two lines here, one of the horizontal ones and one of the vertical ones, and apply an equality constraint. This is also the same operation. As you can see now, the sketch turns green and the solver says fully constrained sketch. No problems. We close the sketch, and as you can see here in the tree view, we already created this sketch here, and we have several information in our data tab about line width and about point colors and things like that. They don't mean something of importance at the moment. So for our first 3D operation, we make sure that the sketch is selected. We can click on the sketch to select it if it is unselected. If I click in empty 3D space, as you can see, the sketch gets unselected. And the data tab now is empty. So I click on the sketch to mark it, to highlight it, and then I click on the pad icon. The pad icon will ask me now how about the length to be padded. Since we want to have a complete cube, I will pad the sketch about 200 millimeters, and I will pad it symmetrically to the sketch plane. I take this box here and I say OK. We made now a pad, and if I go to axometric view and if I say fit all, congratulations, we have just made our first 3D object. So now we continue with the pockets. To do our first pocket, we click on the top face here to select it. We then choose to create a new sketch, and since we have selected a face, the sketch will be mapped to this face. As you can see, the origin and these two axes are drawn automatically. So I will now draw a circle. I will click on the icon. And for our first try, I will click here in, let's say, empty space one time. I will move the mouse and I will click a second time here in empty space. This is to demonstrate you something. At the moment, I have 3 degrees of freedom left in the sketch. What are these 3 degrees of freedom? Of course, it is, if we look at the lower right corner here, it is the x and the y coordinate of the midpoint of the circle. And if I would also specify a radius or the diameter of the circle, we would have all information needed to fully constrain the circle. Okay, so I will just do that. I will select the midpoint of the circle. It turns green, so it is now selected. I will press Ctrl and hold it pressed, and I will also select here the origin. And then I will constrain these 2 points here with a coincidence constraint. As you can see, these 2 points are now the same. And I just removed 2 degrees of freedom here in the sketch. So I will now highlight this circle, and I will constrain it with a radius constraint. The radius constraint I will use is 31.25 millimeters. I will press enter, and as you can see, the sketch turns green and the solver says fully constrained sketch. Everything ready to go. I will close the sketch, and then I will use the pocket icon to create a pocket in the cube. The pocket, the direction of a pocket will be normal to the place the sketch is on. And so I click on the icon, and then I have the possibility to choose if I want to insert a dimension, how deep the pocket will be. Should it also be symmetric to plane, reversed, or things like that. And if I say, oh, I want to have the pocket through the complete object, I would choose as well, something like a constraint, you can call it, for pocket through all. Or you can say no to the first face you meet, or up to a certain face I will select. But we will leave it to dimension. We will select this 5 millimeter length, which is default value, and we will replace it with 75 millimeters. We say OK, and if we return to axiometric view, we can see that we already did our first pocket. We can change here to wireframe mode, and you see we did our first pocket. That's how it looks like. We switch back to as-is mode. We click on the face here, on the top face, to select it, and now we'll draw the next sketch. Now this time I will click on the circle icon here, and I will show you something. If you move the cursor over an X here, just look at the lower right corner where your cursor is. It will show you a small symbol because, as I said earlier, we had set up in the preferences an auto constraining, saying that there is an algorithm in the background running all the time. Whatever the algorithm does recognize, it should display. So we could here make the center of the circle sit on the axis. Or if we move close enough to the origin, we could constrain the center of the circle to be identical with the origin. If I click now and move my mouse outwards, you see the center of the circle is identical with the origin. So I click one more time here and have only 1 degree of freedom left because the center is already constrained to the origin, the center of the circle here. So we do the same as we did before. We highlight the circle and we constrain it with a radius. This time our radius is 62.5 millimeters. We say OK. The sketch is fully constrained. We close the sketch. We apply the pocket operation, and we will replace the length or the depth of the pocket with 50 millimeters. We say OK. We will highlight this face again. We will choose the sketcher once more. We will create a circle. We will move the cursor as close to the origin as we can get, so that in the lower right corner there is this small dot appearing. So now if we click here and we click one more time here, we made another circle with 1 degree of freedom. We highlight the circle, we constrain a radius of 93.75 millimeters. Okay, we close the sketch, we apply the pocket operation, and we will replace this 5 millimeters length value with 25 millimeters of length. We say OK, and if we change to axisymmetric view, we say fit all. Let's also switch to wireframe mode. We can see all 3 pockets are now done on the first face of the cube. These 3 pockets we must now also apply to all other faces of the cube to get a complete Turner's cube. So now for the 3 pockets on the next side, let's say we will choose this face here. We select it, and then we choose the sketcher. We draw a circle. We make sure that the origin is caught, and then we will draw our circle. We will highlight the circle, apply a radius of 31 point, or in my case, 25 millimeters. We close the sketch, we apply pocket operation and a depth of 75 millimeters. We choose the face once more, open up sketcher, draw a circle here to the origin constraint. We highlight the circle, we apply a radius of 62.5 millimeters. We close the sketch, and the length of the pocket here is 50 millimeters. We do it a third time. Let's draw a circle. Center of the circle should be sited at the origin. Now we will highlight the circle, apply a radius, and radius should be 93.75 millimeters. We close the sketch, we apply the pocket operation. The length should be 25 millimeters, and that's it. We just completed the 3 pockets on the second side. Now I know that this is a little bit tedious. You can try to speed up things by using keyboard shortcuts. You have a possibility in FreeCAD to assign keyboard shortcuts to commands you will use very often. To do this, you select Tools, Customize, and then you can say Keyboard, and then you choose which menu you want. For instance, we want to have a look at the sketcher and create circle is currently assigned no keyboard shortcut. This creates circle here with the icon. Yes, that's the correct command. In my case, I assigned a K. That's an abbreviation for the German word Kreis, in English circle. So I choose keyboard shortcuts. You can also use, of course, the Alt key and the Control key and the Shift key and some combinations and things like that. I try to assign shortcuts which are easy to remember. Okay, so now on the next phase, we'll call the sketcher. We will now draw a circle here. We will assign a radius to the circle of 31,25 millimeters. Okay. A pocket of 75 millimeters. Now we will do another sketch with the next circle here. We will apply a radius of 62.5 millimeters. Close the sketch. Apply pocket operation with a depth of 50 millimeters. Okay. Highlight the face. Call the sketcher. Create a circle. Make sure the center of the circle will be identical with the origin of the sketch. And then let's highlight the circle here, apply a radius of 93.75. We close the sketch, we apply pocket operation with a depth of 25 millimeters. And here we go. Now with the next phase, sketch, circle here. Now a radius of 31.25. Close here. Pocket operation, 75 millimeters. Very good. Now the next sketch, circle, midpoint here, midpoint here. Now let's give it a radius of 62.5 millimeters. Close the sketch. Apply pocket, 50 length. Now select this face. Select the sketcher. Circle. Here we go. Apply radius of 93.75. Close. Pocket, 25 millimeters length. Now let's do this face here. We have our circle. We have a radius of 31,25 millimeters. We close the sketch. Apply pocket, 75 millimeters. Choose face. Create sketch. Create circle. Constraint circle 62.5 millimeters. We close the sketch. We apply pocket. Length should be 50 millimeters. And now for the last pocket on this side. We draw up the circle. We mark the circle. And we say 93.75 millimeters. We close the sketch. We apply pocket operation. 25 should be the depth. And that's it. Now for the last phase, we call up the sketcher, say pocket. Here we will have 31.25. Oh, excuse me for saying point and meaning comma. We will have pocket operation of 75 millimeters length. And now one more time. Let's mark the circle here. Apply a radius of 62.5 millimeters. Apply pocket operation. The length should be 50 millimeters. Now the last time, let's mark the face, call the sketcher, draw a circle, apply a radius to the circle of 93.75 millimeters and apply a pocket. with a length of 25mm. Now go back to Axometric View, save it all, and congratulations, we have just completed the Turner's Cube. Don't forget to save your file, and I can only cite the manual of the video game Commander Keen. It's quite an old game from DOS age. The manual said, save your game often, you'll be glad you did. So we have reached now the end of the first lesson, and I would say feel free to comment, and thanks for watching, and well, maybe see you in another video. Bye!